Welcome, everybody, to the American Space Museum. We're here in our shuttle gallery with a special guest that knows everything about NASA parachutes. Welcome, Ty Bowen.
Hi, Mark.
Good to see you here. Yep, well, glad to have you here. Of course, our program is Stay Curious, where we've been bringing you 7 months of programming during this pandemic, brought to you by our nonprofit foundation, the U.S. Space Walk of Fame, that is the nonprofit foundation over our American Space Museum here in downtown Titusville. And we are bringing you this special program. Ty Bowen has worked on the solid rocket boosters of the Space Shuttle era, those two, I call them gigantic pop bottle rockets, if you will, that got the shuttle, mostly its boost its first 20 miles. Then they ejected those SRBs, and then these parachutes come out, and Ty is going to tell us a little bit about that and their processing. So we're so glad to have you with us. Our program has been so important to reach out during our nonprofit during this time. Yep. And we've got our COVID barrier here between us. We wore masks beforehand. Ty, so I don't forget about, we want you to have a Stay Curious mask for when you go shopping. And there's a pen that's got a smartphone knob on the end of it there. Right. So before I forget to give you that.
Appreciate it, Mark.
But we're grateful that you're here. And who knows anything about parachutes? Not me, and I think I know a little bit about some of the hardware of the space program. So Ty, tell us first a little bit about your background and where'd you grow up and how'd you get down here about the year 2000 to start working on the space shuttle?
Well, I grew up in North Canton, Ohio.
Great.
And went to University of Akron after high school.
The Akron Zips, and I'm a Buckeye too,
Zips.
So we talked about that yesterday on the phone, and I know the Akron-Canton area really well, home of one of the coolest Hall of Fames and smallest ones, the
Pro Football
Hall of Fame. Yep.
I've got some friends that used to skydive into that, doing demos for the football team.
So you're a skydiver. Marty, here's a picture of Ty underneath one of the shuttle orbiters. I think that was Endeavor.
I can't remember which one this was.
And
yep, I think so. And then a picture from one of my skydives.
And look at that beautiful, freed like a bird floating in on there.
It's fun.
When did you get hooked on skydiving?
Well, while I was in college, I was doing mechanical engineering courses, and I met some skydivers. I was taking flying lessons at the time, and met these skydivers, and it was the winter time. So it was too cold for skydiving, and they were going to go to this wind tunnel that was in Tennessee. And it's an indoor wind tunnel where the air comes out of the floor in a vertical column, and you actually fly on this wind column. So I went down there to Tennessee with these guys just to see what it was about, and I got in the wind tunnel and I loved it. It was fun. I learned how to fly my body in the air like the skydivers do, and I enjoyed it so much that I actually went back about a month later, spent the weekend there, and flew.
Was that in Gatlinburg?
Yes.
Yeah.
Right next to Gatlinburg. It's in Pigeon Forge, Tennessee.
Pigeon Forge, yep.
Yep. It was called Flyaway.
Okay.
And that was in early 90s. So I had so much fun there, I applied for a job and told them I could work there seasonally whenever I wasn't in college. And they hired me. So while I was working at the wind tunnel, I ended up meeting a bunch of people in the skydiving industry that would pass through. And I worked there seasonally for about 2 years, and when I was getting ready to graduate from University of Akron, I didn't have a job lined up yet, and I was talking to some of my skydiving friends here in Florida, and they says, we could probably get you a job, working at one of these places to hold you over till you find a real job. And I came down for spring break, my last spring break, and did a bunch of skydiving over in Zephyr Hills for the Easter Boogie is what they called it, and stopped in DeLand, which is it's really a focal point for skydiving industry.
North of here, outside of Daytona, DeLand.
Yep, about 20 minutes inland from Daytona. There's a lot of manufacturers there for the skydiving industry, for sport and military gear, the harness container systems that we wear, and then the parachutes that get packed inside.
Made in DeLand.
Made in DeLand.
Cool.
Yep.
Did not know that.
So filled out an application to work at one of the places that my friend recommended, and didn't think anything of it. Went back home, got back into school, and got a phone call about 3-4 weeks later. This is, when can you start?
Wonderful.
So as soon as I graduated, got everything cleaned up in
Akron,
Ohio. and-
versus Florida in the wintertime.
Yeah.
Weighing that out there, I think.
Yep. So that's what got me down in the skydiving industry in Florida. And then I worked in that industry for about 12 years, 4 years at one manufacturer, about 8 years at another.
Wonderful.
And then in September of 2003, I was looking for another way to advance my career, and I was looking around at different jobs. And I just figured, well, what's going on out at the Space Center with the parachutes out there? So I found a phone number of a guy that worked out there, and he was a skydiver as well. And he had long quit jumping, but he'd been working out there. So I cold called him at home. And I says, hey, you don't know who I am, but I'm so-and-so, and I'm interested in getting a job out there. And he passed along the information for his manager, and I called him up, and as luck would have it, they said they were getting ready to add another engineer to their staff anyhow. And I was surprised that they were going to, because this was after the Columbia accident, and we weren't flying. So I was actually hired before we did the return to flight STS-114.
Wow. Interesting.
And I started December of '03.
Okay, that's interesting. Opportunity knocks, and you're ready
Yeah.
for it. Ty, behind you is your nameplate there. Would you grab that and bring that over here, and I can
Sure.
replace that with. We're talking to Ty Bowen here, and he spent a good decade working with the solid rocket boosters of the Space Shuttle era, and so you came on board the return to flight STS-114. Actually, across from you is the crew there, being led by I'm having a brain blank there. The commander, Eileen Collins,
Yep.
of STS-114, the return to flight after Columbia, and so we wanted to make sure you knew Ty, his name there, and. So you brought some things with you, and you've also got a nice little PowerPoint on paper there for us.
Yeah, printed out a bunch of pictures, got a little bit of show and tell.
But first, what's appropriate to get to first? The pictures you have there, Ty, of the USA, United Space Alliance's SRB facilities.
Yep, we can
is
go
that a
through
good
the
thing to start out with there?
Yeah, we can go through the facility.
Yeah, go through
then
that.
I'll transition over to some of the history of what we did there, and then how we got into supporting the Aries
We've
program.
got some other show and tell. The United Space Alliance was the overall contractor that managed the space shuttle, I guess this last decade, since from 2003 to 2011, when we had the last orbiter fly. So he's got a great aerial there and some other show and tell. Go ahead there, Ty.
Okay. So parachute facility is in this part of the picture here. Unfortunately, this facility is no longer there. The main entrance to the facility was right about here, so we'd all park out here and go through the main entrance. It was a very long building. This big rectangular section you see right here, we had 4 long packing lanes. There were 3 long lanes on this side. Then we had the high bay area where we could stack taller stuff with an overhead crane. Offices were behind that, and then we had the 4th lane, which is right here. Now, this entire facility had an overhead monorail system, and it was basically like a meat packing plant with these hooks that were on racks that would roll on an overhead train system.
Pictures. You're going to take us inside there with your pictures.
We'll have some of the
Great.
pictures
Super.
of that. So there was overhead monorail on all 4 of these lanes, and then that also extended to this long section right here, which was outside. This was just a covered roof area. And the monorails all came out here to this section. Now, after a flight, when the recovery ships would bring the parachutes back from the sea.
Marty needs to pan out for that. Show the proximity of
Okay.
Marty. Pan out.
Now, this was across the river from us, but the retrieval ships, the Liberty Star and the Freedom Star, would recover the boosters and the parachutes and bring them back, and that occurred at Hangar AF. And then I've got pictures of this for later of the parachutes coming in on the reels. And they would deliver those right here.
The parachutes on the
Parachutes
ships
on the
were
reels.
wound up on reels, you're saying, huh?
Yeah, it was fishing reels, like fishing nets.
All right.
Really large reels for reeling in fishing nets, and they were converted and adapted for reeling in the parachutes to get them out of the ocean. So those would get delivered to our facility here. When they were on the ship, what was interesting is we would always make sure they stayed wet. So they had hose systems on these reels that would keep the parachutes wet with salt water for the entire trip back. And then as soon as they got to us, we would put them in here, and we had a hose system that we would hook up to the covers, and we would start rinsing them with fresh water and keep the fresh water running. So we never let them dry out.
Okay.
What would happen with the parachutes is if it dries out, the salt in the salt water would crystallize. And then you have these salt crystals inside the webbing, and when the webbing gets agitated and moved from handling, packing, and flight, it would damage those fibers.
Pan out a little, Marty, to show him. He's talking there.
So we call this section the defoul deck. And this is where we would take the reels, we'd unroll one of the parachutes, and it was still wet. We'd keep it soaked down with fresh water. And we would basically untangle them, get all the suspension lines, dispersion bridles, and main risers disconnected from it. And then we would hang all of those on the overhead monorail hooks. And then they would roll into a large 30,000 gallon wash tank that was back here. And it was an above ground wash tank. It had this big door that would seal on the front. It was kind of like a giant submarine hatch. And it was maybe a 40 or 50 foot long room, about 10 feet wide. And the walls were about 6 feet high. The door was about that height. And we would fill that with water, and it had these giant sprinkler systems in there, and we would cycle and rinse the water through while the parachute was suspended and draped inside here. And the water would fill up to about 3-4 feet deep. We would keep running those through the washer until the salinity of the water was below a certain level, so that we knew we had all the salt water rinsed out of the parachute.
So is that hours or a day or a couple of days?
It would take about 6 hours to get one washed.
One parachute to get all the salt out of it.
Yep, we had to get all the salt out of it so that the crystals, or so that the salt water wouldn't crystallize, and then that would damage the fibers. So once we had it rinsed sufficiently and the salinity of the water checked out okay, we would then drain the tank and roll it into the next room, which was a steam-heated drying room. And we would fill that with like 140 degree air, I believe it was. Whoa. And the parachute would dry in there, and if it was off-season, wintertime here in Florida, it's not as humid, so then it would take maybe 6 hours to dry. But if it was a real hot, humid summertime event, then it could take up to 10, 12 hours to get the parachute dry.
Now, Ty's going to show us pictures of this. These rooms are gigantic that these parachutes are in.
So as soon as it was dry, then we would roll it into one of these long lanes here inside, with long packing lanes, and then we would start doing the damage mapping. And that would get pretty interesting. The boosters, right before they land in the water, at about 1,000 feet, they would actually sever the nozzle off the bottom of the booster. And if you look at the videos of the boosters coming into land, you'll see this big black plume come out from the bottom of the booster, and as the booster's descending, this black plume goes up around the booster. That's all of the debris and the smoke from severing the nozzle. And you'll see the nozzle falls away, lands in the water before the booster does. And the nozzle just sinks, and it's blown to pieces.
Okay.
The reason they were jettisoning the nozzle that way is they learned that if they didn't do that, when the booster would hit the water with the aft end first, that nozzle would break up, and all of that debris was damaging the thrust vector control system that would gimbal the nozzle. So to reduce the damage for that, they would sever the nozzle and jettison that before they landed in the water. But that big black plume that you would see come up around the booster, it was all sorts of carbon debris and smoke and everything else.
Like pyrotechnics,
Yeah, it was a pyrotechnic charge that would blow that nozzle off. So you'd get all this carbon debris. The nozzle's made of all these multiple layers of like some sort of laminated Kevlar and carbon fiber. Not sure exactly what all compounds were used in it, but had a lot of black carbon layers to it. And those would be real hot, and they're very sharp. And all of that would come up around the booster, and some of it would get captured in the parachute.
Oh, okay.
So we'd end up with damaged ribbons on the parachute, and we would have to fix those torn parachute ribbons, We'd also get melted ones if some of the debris was hot. So we had burn damage and we had tear damage. And we would average 50 to 100 repair locations per parachute. So
Well, you're going to show us inside this facility. What picture do you have behind there? Oh, you're still completing the process. After that,
after we would do the repair operations here, then it would go to the packing operation. And I've got photos I'll be able to show you of the packing operation. That still used the overhead monorail to help move the parachutes. And then we had...
yeah, go ahead and show the next picture of the inside.
That would be over to here.
No, the one you had behind it.
I'm sorry.
This one here.
Yep,
yeah.
this one here.
That gives the people a dramatic look immediately
Yep.
of how gigantic that facility is. And
so this is in the left side of the facility where I said we had 3 lanes. You can see we got 3 long packing tables here. Thank you. So that was the first table. This is the middle table where this technician's working. That was Tom. And then the third table was behind him here. So this is the overhead monorail system. And it's kind of like meat hooks in a packing factory. And the canopy is suspended on hooks up here. And what you see draped across here is more canopy. These things are very long. Looks like he was working on this looks like it was a main parachute here with a 2-inch wide radials on it.
now behind you, the pieces you have there, is that part of this parachute system?
The pieces I have there was from the Aries program, but they're very similar to some of the SRB stuff.
Could we show those to show how heavy duty this is, just to give our an idea that you're not talking about string here. You're talking about a canvas.
This is a real heavy nylon webbing.
Stronger than anything you've ever used to tie anything down on the top of your car or anything like that, for sure. Look at that, how heavy that is.
Yeah, so this is type 26 nylon webbing, and we used this heavy webbing for the parachute riser itself. This would be the webbing that connected right at the deck fittings and went up, and then we had a lighter webbing which went to the dispersion bridles, which separated a little bit more, and then we went to a 1-inch wide webbing that spread out and was the connection at the skirt of the parachute. So you had the riser.
So this is more connected to the SRB itself.
Yeah, these were at the SRB, and this webbing is 15,000 pounds tensile strength.
Wow.
So
almost a ton. No, 15,000.
15,000 pounds.
7 tons.
Yeah, just for one layer.
Wow.
So this particular riser, which was from the Aries program, that was 6 plies on one riser.
So you've got a ply of 6 here, Marty, like this.
Yep.
That for one.
For one riser. So that was 90,000 pounds.
And a riser is basically one of the extensions up to the canopy.
It's the lower structure of the load path going up to the parachute.
Yeah, let me show you that. Since we're walking around here, you see how thick that is, and this has got a special little sewing on that.
Yep.
Got to strengthen it there.
This was the splice to join the 2 ends.
Oh, okay.
Yep.
Oh,
so
that's how you.
Yeah, when we built this, and I've got a funny story when we get to this one later. When we build these, we actually build it as a continuous loop. So we have to join those 2 ends, and they would overlap. And then after they overlapped, we would do this stitch pattern of 5 rows of zigzag stitching.
I'll show you what we're talking about there. The stitching on that to connect 2 pieces. Huh.
Yep.
What's that made out of? That feels like metal almost. That stitching.
Funny story here. We'll get to it.
Okay. All right. Okay.
Yep. But you can see this canopy.
Sorry to interrupt
Actually,
there, but I wanted to get a kind of a visual since we're standing up here how all this stuff looks.
So these canopies, a lot of people think that's made out of a solid panel of fabric, but it's actually made of all webbing. So it's got tiny slots in between all the pieces of webbing, and that's to control the amount of porosity through the parachute.
Porosity.
Porosity is the amount of air that's actually able to go through the parachute.
Kind of a derivative of porous.
Yeah.
Is that right?
Yep, kind of like a screen door. If you have a screen
Or a
door with
sieve,
really
a
big
sieve.
openings,
Gotcha.
then it's very porous, has a high porosity. If you have real small openings, you have a lower porosity.
Right.
So to help control the opening and flight characteristics of the parachute, we would determine what porosity we needed. And I didn't do much of those calculations. We had a lot of really good analytical engineers that did that for us, and they did an excellent job. So this parachute was made of a whole bunch of pieces of webbing that's all held together with smaller webbing that ran in the vertical direction. So you would have your suspension lines, which are hanging here, and those run all the way up to the top of the parachute, which would be, it's called the radial. And then we would have mini radials in between, because the radials might be 2 to 3 feet wide. And then when you run webbing from one side to the other, it's obviously going to flip all over. So we would run lightweight mini radials up there, and that's to help tie it all together, so it's like this big mesh panel. And that actually formed the panels of the parachute.
Wow.
It was much stronger that way than using fabric, and again, we could control the porosity of it for the flight characteristics.
Very interesting.
You can see this sewing machine here in front of
It's
the table.
a sewing machine on wheels there.
Yep, it's on wheels. It's hard to move the work when the main parachute weighs 2,000 pounds.
And how long is it? What are we looking at lengthwise here? 15, 30 feet, 20 feet, 20 feet?
The parachute itself,
Uh-huh.
when you took the parachute with the suspension lines and the dispersion bridles and the risers, the whole thing was about 300 feet long.
All right, so you're talking a football field.
Very long. And the initial main parachutes that were used for the shuttle program, we called them the small mains. They were 115 feet diameter. And they were used for the first 13 shuttle flights.
Okay.
And what they learned was they were impacting the water a little faster than they desired, and they were getting some structural damage and some damage to the thrust vector control system at the bottom. So they came up with a larger main parachute, and it went from 115 feet to 136 feet in diameter.
Okay.
So those were flown from the 14th flight on to the end of the program.
How many times, before I forget to ask you, how many times was a parachute reused? What was the lifespan of them?
It would vary, and it varied depending on the state of the ocean during recovery and any other damage that may have happened during retrieval operations. If it was bad weather and the boats couldn't get to the boosters in a hurry and they had to be out there bobbing up and down in the ocean overnight for 12 hours or so, the whole time that parachute is getting agitated in the water, it's losing lifetime. So we had some chutes.
Because of the salt deteriorating the fabrics.
Mostly it was from the motion.
Oh, okay.
Yeah. It would get flexed and cycled to a certain point.
Like in
to
a
where,
washing machine.
Like in a washing machine.
Yeah, that's not
But the
good.
fibers would start to break down.
Okay.
And it was kind of a weird way to determine when it was starting to get a little bit too much degradation. Is you would handle the webbing with your hands when it was dry, and it would have this crunchy feel to it. It was the only way we could really describe the sensation. It had a crunchy feel. And it was because if you put it under a microscope and you looked at the fibers of the webbing, they looked really hairy and really fuzzy. Brand new webbing, all of the fibers are woven, nice, neat, clean lines, nothing's broken in there. So the more the fibers would get broken down and fuzzed up, you're losing strength, you're losing durability. So
You could feel that with your
You could feel it with your hands.
Ty, huh? Very fascinating.
And we would find an area of the canopy that felt suspect, and we would sometimes cut out a section. And we would put that in our tensile tester, and we would pull test it and see if there was degradation that warranted repairing that section or actually taking that parachute offline and retiring it.
So how many times? Are you talking 4 or
So
5?
coming back to the numbers, we had some parachutes that would be retired around 7 or 8 flights. And memory's a little fuzzy, but I think the most we ever flew one of the main parachutes is about 13 or 14 flights.
Okay. And Marty, we're talking about, I'm going to have you put, Marty go into this picture behind our little easel here
Okay.
with Ty Bowen, so that what we're talking about are the parachutes that brought down the 2 solid rocket boosters, the SRBs, and there are the lines you're talking about. That was the heavy we were just showing. That's the heavy lines.
These would be the risers that are coming down from the deck fittings up here. And when these would land in the water, the parachutes stay connected here at these risers, but at the end of the risers, we had what was called a SWAR. It was a saltwater activated release. So when this release would get immersed in the salt water, it had a pyrotechnic charge that would fire, and it would release one end or one side of that parachute. and then that side of the parachute was able to dangle down below the booster. Because if we didn't let the parachute dangle down under the booster, the whole time the booster's going up and down with the waves, that parachute could be abrading against the side of the booster, against the skirt. So we had a retrieval line, and it's a big long line that was S-folded and hand-tacked along the risers, so that when it hit the water, the saltwater activated releases would release them, but that retrieval line would then pay out and let the parachutes get below the booster.
Wow, never ever thought about something like that. Now, just for the benefit of our viewers, these two boosters are very close together, and we're going to talk to someone in a couple weeks that was actually one of the frogmen that put the plugs on at the bottom. They put air in it so they would float.
That'd be the DOP, the diver-operated plug.
Diver-operated plug. So that's why they're bobbing up there like that. And when this gentleman, Marty was his name, we're going to talk to Rick. Well, we'll get it to you.
Okay.
He's going to tell us about that because he was one of those frogmen. In fact, he said he's on that.
He's in that photo?
Yeah, he's behind the one guy on the left.
Okay.
But he said this was too dangerous. These came down at night, and they don't want them this close.
No, they don't.
And also, Ty, the one on the left is lower. And he said that didn't get enough air in it, and it's going to take longer to drag it back on the tugboat back to Port Canaveral. Just that amount of difference in the profile, he said, is going to create.
It'll take him longer to fill this one, and I'm sure he'll be able to explain this process a lot better.
No, you tell us though. It's fascinating what we're learning here with
what
Ty
they would
Bowen.
do is, the retrieval boats would go up to the boosters, and they would disconnect the parachute from the booster, and then with the boat they would take that over to the retrieval ship. It would be either Liberty Star or Freedom Star, and they would hook a retrieval line up to the parachute and run that up to the big winch that had the reel mounted on it, and then they would reel in these parachutes. So each booster had 3 main parachutes, and then the other item, which is the frustum, which is the nose cone that was above here.
Well, that's right above you there. Actually, one of them.
Yeah, there's
that's
the nose
actually
cone.
one of the few that survived the ocean.
So then the frustum is the truncated cone that's above it. The nose cone went on the top of the frustum.
Marty.
And they would get these parachutes off of these boosters, take those over to the ship, and get those reeled up. Once they had everything disconnected from the booster, they would then install the DOP, the diver-operated plug. They'd have to dive way down to the bottom and insert that plug, and then they had an air hose that ran down to that plug. Then they would start filling this booster full of air. And it would take a while, but these would slowly rise up out of the water, and as they rose up, then they would slowly start to lay down, and then it would be on its side like a log.
Okay.
And then they would hook a tow rope up to that and tow it behind the ship back to the port. Then they'd have to pull the booster up next to the boat so that they could go through the locks. And then they would continue transferring it to the Hangar AF facility.
Sweet. What a process. Marty, pan out a little bit so above that we can show the very tip of this. We're proud to have one of these because out of 135 shuttle launches, 270 SRBs flew. There's just a handful of these top sections that didn't sink in the ocean, and that's kind of a cool thing that that's cool that we have one of them here.
Yep.
And we have
so that would be right here in this photo.
Okay.
And then the rest of this tapered section below the nose cone was called the frustum, and the main parachutes and the drogue parachute are actually contained all within that frustum section.
Are you in that picture?
I'm not.
Is that a group of SRB people or parachute people? I'm not sure.
Yeah, it looks like a group of SRB people. That photo is probably taken over at the ARF, and that's where they would put together the forward skirt extension and join the frustum and mate the parachutes.
Good,
inside.
sweet. Well, unless you got any more to show on your picture there, let's sit down and look at some of Ty Bowen's pictures of the actual inside of this entire operation. By the way, Marty, you got to zoom in on his cool T-shirt there. Parachute Refurbishment Facility.
Had to dig this one out of storage.
Did you? Good.
Yeah.
Still fits, huh?
Still fits.
Good old golf shirt, it looks
Yep.
like now.
It's a little bit faded, but I didn't want to wear it out.
That's a neat little logo. I've never seen that logo.
Yeah, this was the
of
USA
all the things I
SRB
run
Element
across.
logo.
Yeah. That's sweet. Good,
Yep.
good.
I'd love to find some nice artwork of it that I could actually digitize it and re-embroider
Well,
a
I
new
run
shirt
across
for myself.
it. You'll be the first one I call.
Okay.
As we go through some of our stuff that just literally walks in the door at our nonprofit that we either put on eBay or our auction, and we're getting another auction together here in a few months. But eBay's got over 100 items up right now of things that
very good.
you worked with and things like that goes to good homes and helps support our museum. Well, show us what you brought here in pictures here, the inside of this.
I hope Marty's able to zoom in on them pretty decent.
He's awesome with the camera.
All right.
Marty Winkle, our cameraman and co-producer of our program, and
So-
he's responsible for getting Ty and many of our guests that we're bringing you now here. Go ahead, Ty.
This photo is actually just very similar to this one here that I brought. I forgot I had this one in storage. I'd printed this one.
Use that pen I gave you if you got it.
Yep. So this parachute is same as what we had here. I forgot I had this large picture, so I brought that one in. So we'll move on here. Now this is an Aries parachute, but this does demonstrate how we would handle these large parachutes at the PRF for packing. You can see we're still using the overhead monorail system, and we've got this parachute actually suspended from that. The table is underneath it, but it's not laying on the table. And I hope it shows up here on the camera. But we had a little platform here that sunk down in the floor. And this metal canister here, we called it the packing can. And we'd take the deployment bag, whether it was for the main or for the drogue, whichever parachute we were packing. We'd put it in the proper packing can, secure the bag, and then we would start packing the parachute into the can.
Oh, okay.
And not sure if you can tell, but there's actually somebody inside the can with the parachute right now.
Well, I can see a woman's, it
Yep,
looks like a
there's-
lady in the
Yep,
back
there's
of
a lady
her.
right there.
White, she's wearing white.
Appears
you
to
can
be
see-
Marcia.
Wow. So she's standing on this parachute, packing
Yep,
it down,
she's
literally.
kneeling on that parachute. Inside the bag, we would have locations where we would use cotton brake ties to tie the parachute inside the bag.
Wow.
And that was to help get a proper sequenced parachute deployment. We didn't want all this parachute coming out of the bag as one big blob.
Right.
So we would
Gotcha.
actually retain top sections of the parachute inside the bag with pieces of cotton webbing that would purposely break when they got loaded. So when the bag would open, part of the parachute would be coming out as the load pulls it away from the bag, and we would control the deployment that way. So she's in there making these tie connections between the parachute and the loops that are on the inside of the bag. So as they put more in the can, they just roll the parachute forward and drop it in. And without this overhead monorail system, packing these parachutes would have been a real nightmare, because the main parachutes, each one weighs 2,000 pounds.
Wow,
And
a ton.
that was the same whether it was for the SRBs for the shuttle program, or if it was for the parachutes that we developed for the Aries program. The shuttle program parachutes were all nylon, and they were 136 feet in diameter for the mains. The mains on the Aries program, which were red, white, and blue, they were 150 feet in diameter. But when we were developing the Aries program hardware, they gave us the requirements that it had to have the same pack volume, and it also had to have the same weight, because they wanted to use the same surface area volume as what was allocated for SRB. So we ended up doing a hybrid construction with these parachutes. We had Kevlar webbing on them, but all of the horizontal webbing components of the canopy were still nylon. So we went to a Kevlar load path, and then all of the ribbons were nylon still.
Well, the Aries program was changed to what we're calling the Artemis, I guess. But these were for which vehicle? What hardware?
This hardware was for Aries 1X test flight.
For the Orion spacecraft.
the Orion spacecraft had its own parachutes for recovering the capsule.
Okay.
These for recovering the first stage of Aries.
Oh, okay. Okay. All right.
Yeah, the Aries booster was a 5-segment booster, and the shuttle boosters were a 4-segment booster.
Right. Solid rocket boosters on them. Yes.
So
okay.
that's why we had to make the parachutes larger, 150
Gotcha.
feet in diameter. The empty booster for the shuttle was about 180 to 190,000 pounds that we were recovering with the parachute system. And for Aries, with the 5th motor segment, that bumped up the total weight to about 220,000 pounds. So we had to have stronger parachutes. They had to be larger so that they could handle the extra weight and still land at a reasonable velocity.
No easy task.
We had a good group of analytical engineers and design people that helped us put together a really good system for the Aries program.
Okay.
But I wanted to include this photo because it showed how we would handle these
Yeah.
parachutes
Very clear.
to get them packed into these bags. So trying to get all that into that bag,
Yeah.
it could be pretty tight. So we had what was called a spider press. And this appears to be, this looks like a solid rocket booster main parachute. And it's got 1-inch suspension line webbing, and I can tell from the corner of the can here that this is one of the pie-shaped SRB main bags. So you can see the parachute is in here. We've got all the suspension lines hanging out. This big blue piece that you see is a press plate. It was about 3 feet in diameter. It was like a 1-inch piece of aluminum, and we covered it with fabric. And then this was a big hydraulic cylinder. And at the top of the cylinder, we had all these webbing legs that came down and they connected around the parachute can. And it was a big hydraulic press that we would use to squish this parachute down into the bag. So if you tried to close this bag by hand, you couldn't do it. You couldn't get the parachute packed down and hold it there in a dense enough configuration to get the flaps closed. So we would put the spider press on it and press the parachute down into the bag, and we would usually time this operation to happen towards the end of the work shift, and then we'd go home for the night. And then when the technicians got there in the morning, everything had relaxed and kind of assumed that pressed position, and then they would put the reefing line cutters in. The reefing line cutter pockets are sticking out around the edges. They'd put the reefing line cutters in it, get the ordnance connected up, get that inspected, make sure it was ready to go. Then they would take the spider press off and close that set of flaps before the parachute started to try to grow back up again. So it was a timely thing that you had to get accomplished.
Very interesting.
Yes, Marty?
Sorry about that. Is what you showed there, is that what we have over here on the left?
Over on the left. That green pack right there?
Yeah.
That is an SRB pilot parachute pack. You're looking at this one right here?
Yeah.
Yeah, this was the SRB pilot parachute. This is about a 10-foot diameter parachute, and this pack was actually contained inside this nose cone. And it sat on top of the drogue parachute. So the drogue parachute was right about here. Then you had the pilot parachute pack sitting here, which is covered by the nose cone. When the nose cone would be jettisoned at about 15,000 feet, the nose cone aerodynamic drag would deploy this pack. And there were energy modulators that were on here, and I may have a photo of that. The energy modulators is webbing that is folded back and forth on itself and has stitching put through it, and that stitching is intended to rip. And when it rips, it helps limit the shock load that's going into that webbing. Because when the nose cone comes off, it's falling around 350 mile an hour at that point. So we don't want the nose cone to try to deploy this too abruptly. So we would have the energy modulators there where the stitching would rip and let the webbing kind of stretch out and elongate to reduce the shock load and the deployment speed of this pilot pack. So this is a mock-up of the pilot pack. It just doesn't have the modulators. It would be stacked on top and tied down. And then the modulators would be connected to your nose cap.
In front of Ty, while he's standing there, is the thermal protection door of the shuttle, space shuttle uh, uh, parachute system, right, shown right there.
Yep, the orbiter drag chute.
That tumbles down the runway, and that was added after, I don't know, STS first 35 or 40 missions, wasn't it?
I can't remember exactly when they added it.
They wanted they had problems with the brakes burning up, so they put a drogue chute on there.
Yep.
So, did you have deal with that too, Ty?
We would pack this parachute at our facility. We would do the maintenance and repair of it in repacks, and it was very similar to the work that we would do for the SRB parachutes. We just didn't have to deal with any of the saltwater damage that might occur. So with this one, it was mostly abrasion and wear and tear from regular use. I can't remember how many flights we were able to put on that one, though.
Yeah.
This was a 40-foot diameter parachute, and it was deployed with a mortar, and the mortar had a sabot, which is like a little hollow slug, and it had a 10-foot pilot chute in it. So when the orbiter would land, it would eject the thermal cover, and after the thermal cover was ejected, then the mortar would fire out the sabot, which would pull out the pilot chute, and then the pilot chute would pull out the 40-foot drogue chute, or drag chute.
Always a beautiful sight. Good, yeah. Well, good. Let's get through these other photos you brought here. Yeah, go ahead.
Interesting story with this one
Yeah.
is, I can't remember the STS number, but it was when John Glenn returned to flight, and he
95, yes.
That was STS 95?
Yep,
Okay.
yep.
On the John Glenn flight at launch, this cover fell off.
Oh, no. Wow.
So the story I heard is when the pad rats got out there for cleaning up the pad, they found that thermal shield sitting there. So on that flight, the parachute pack and the mortar, that whole system was exposed to the cosmic radiation up there and vacuum of space and so forth. So there was concern over whether or not that parachute would function correctly. So when they landed that time, they did not deploy the parachute.
Okay. Interesting. John Glenn had a re-entry light come on that his heat shield had slipped in during his famous Mercury 3 orbit, so they left the retro rocket pack on as security,
as further ablative.
And that he says a real fireball here as he saw pieces of that fly off. I didn't know that about the famous STS-95. That would be pretty something to think about. Re-entry without the protection system too. Very interesting. Well, we're here with Ty Bowen, who's a NASA parachute expert. He was a design and operations engineer for 10 years with United Space Alliance during the last decade of our fabulous 30-year history. And he's got another group of photos here we're going to go through here to help you stay curious. Everything and more that you want to know about parachutes. Very fascinating. Go ahead, Ty.
Okay, so a few minutes ago we were talking about the pilot parachute pack that was over there, and I do have a photo that shows the energy modulators. And we had 3 different colors. We had a green modulator, an orange modulator, and a white modulator. And that went to the 3 connection points that were on the nose cone, on the underside of it. So those were what connected to the nose cone. And when the nose cone was ejected, it would pull on these bridle legs, which were connected to these energy modulators. It would slow down the hit so that this didn't deploy too fast. It would disconnect from where it was tied to the top of this drogue pack. The drogue pack is the white and yellow pack you see here. So the pilot chute would deploy, and as soon as the pilot chute deployed, it would then pull off the drogue from the top of the booster, and then the drogue would deploy. The drogue parachute, this pack, weighed about 1,200 pounds. And the SRB drogue was 54 feet in diameter, if I remember correctly. And this deployment bag was made out of Spectra cloth, and the yellow webbing that you see is actually Kevlar webbing. So this is a Spectra Kevlar constructed bag.
Okay.
And the main bags for the main parachutes were made out of a nylon parapack cloth with nylon webbing, and they actually had woven Teflon fabric on the inside of them to help prevent burning. The main parachutes would deploy so fast sometimes, and they would be going past the flaps of the bag, that it could actually burn the parachute as it deployed.
Really, the friction.
The friction, and it would happen so fast. And if you watch films of the main parachutes inflating, you put it in slow motion, main parachutes typically inflate like a light bulb. You know, it gets stretched out long, and a lot of people think a parachute opens at the bottom first. They actually open at the top first.
Okay.
You have the low pressure in the center, and as the parachute gets stretched out, the wind channel allows pressure to come up the center, and then they actually inflate like a light bulb from the top down. So we would call it light bulbing. You would see the top of the parachute start to inflate, and then it would progress downwards.
Okay.
Well, before that would happen, and because of the dynamics when a main parachute would come out, sometimes the top of the parachute, called the vent, would be dancing back and forth before that pressure got up there to inflate it. The top of the parachute could actually swing down and impact the side of the parachute and come back up.
Uh-huh.
And when that would happen, it would happen so fast that it would actually cause friction burns. It would be just a glancing blow, but it had enough pressure that it generated heat to actually melt the nylon ribbons. And a lot of times when we would have bad damage on a parachute, sometimes we would get a whole section that would blow out, like a 10-foot rip in the parachute or whatever. Most of the time that was contributed to the vent dancing around and impacting, actually hurting itself.
Fascinating. What you got next there?
So this white structure was called the ISO grid, and this is what the 3 main parachute packs connected to, and this then bolted inside the frustum underneath the nose cone. So this was a green nylon parachute pack, and it had the green nylon webbing on it. And when we put them in the isogrid, there was hardware that we would bolt them to these legs here in the middle and then bolt them around the perimeter so that these packs were actually hanging down off of this top ring. So once they're hanging off the top ring, we would put webbing all the way around it, the circumferential straps, and we would ratchet those up real tight and then secure them with connector links. And that held the 3 packs real tight to the isogrid. And then the isogrid would get mated into the skirt extension, and then the frustum placed over it.
Neat. Okay.
So this is looking up to the inside of the frustum, and you can see we got the 3 main parachute
From the
packs
bottom
here.
part,
This is looking up from the
yeah.
bottom, and these are the main risers coming out, and you can see the deck fittings are here. We got 4 deck fittings at the end of each riser group, and those are the fittings that would get bolted to the top of the booster.
Okay. Like we had over there.
Yeah.
Okay.
So
Oh, it's the same photo.
it's the same photo.
Great.
So I had brought this one. I tried to put these in kind of the order that would happen.
Yeah.
And so, you know, this is what it looks like before. This is what it looks like after. So we discussed this and we were looking at the bigger photo.
Right.
So the parachute is now dangling in the water. It's down below the boosters, and the retrieval guys are going to hook the retrieval lines up to the parachutes, disconnect them from the boosters, take the retrieval line over to the ship. They're going to put that on the reel, and they're going to reel in the parachutes just like you would a giant fishing net. There's 3 main parachutes per booster, 1 drogue parachute, and then 1 pilot parachute. So then I had mentioned how they bring it through the locks to bring it back to Hangar
At
AF.
Port Canaveral, right
Yep.
next to the.
So here's where they had inflated the booster there. They fill it full of air to pump all the water out, and then it can float on its side like a log, and then they tow it back. And when they go through the locks, they have to pull it up next to the ship to better control
And
it.
there's where all your parachutes were on top of that
Yep,
white.
they were all on top of there.
Mm-hmm.
And then the frustum, the cone-shaped section that has the isogrid and the main deployment bags in it, that is still connected to the drogue parachute.
Okay.
Yeah.
So
So
it wasn't okay. So it didn't ditch in the
yeah,
ocean, so you could reuse them.
Let me grab this photo over here.
Yeah.
If Marty's able to see this one. We're really testing out your Zoom capabilities here today. So there was an ordnance ring right here at the bottom of the frustum, and when that ordnance ring fired, that is what let the main parachutes come out of the deployment bags. So the drogue parachute is connected to the top of the frustum. And when the whole booster is under the drogue, it's decelerating. The drogue goes through 3 stages of inflation, from small to medium to full inflation. And then this ordnance ring would fire, and it would separate the frustum from the rest of the booster. When the booster separates from the frustum, as the booster falls away, it's actually pulling the main parachutes out from the deployment bags that are still in the frustum. So that falls away from the frustum. The frustum was being held by the drogue. Now the frustum and the drogue come in and land on their own in the water, and the main parachutes inflate, the booster lands on its own. So when the retrieval ships would get on site to recover that, they'd be recovering the booster with the 3 main parachutes hanging off of it, but they would also be recovering the frustum that had the drogue parachute hanging on it. And they would usually have the frustum parked on the back of the ship. Really can't see it in this photo, but they would bring the frustum back. They would actually pick it up and set it on the back deck next to the parachute reels.
Neat.
So these are the reels. And they
Those
had
are the reels with the parachutes wound up
Yep.
on them. Okay.
So the parachutes are wound up on here, and this is on our defoul deck right there at the corner where I mentioned they got delivered. And this was a protective cover that was put over it, and they would put the sprinkler into the top of the cover and keep them wet. So when they were on the ship, they just kept them wet with salt water. As long as they didn't dry, it was fine. When they got to our PRF facility, then we would put fresh water hoses on there, and then we would start our defoul operations of untangling these. Sometimes they'd come apart real easy. Other times it was a super tangled mess, and it would take a lot of work and a lot of effort to get them untangled. But the whole time that we were doing that operation, we kept them wet. Even when we had them stretched out on the floor, if it's taken a long time to get it straightened out, we'd routinely spray them down with water to keep them from drying out. It could take maybe 4 or 5 hours to do one parachute defoul operation of one parachute. If it was really tangled up, it might take a day to get that thing undone. So after each flight, we had 8 parachute reels that we had to handle, because we had 6 main parachutes and then we had 2 drogue parachutes. And then those would be all cycled through the large wash tank, then through the dryer, and then rolled inside to start the damage mapping.
And just to be clear, this shuttle came back. Well, there's another crew getting parachutes ready for the next flight, right?
Yes.
It's a continuous
Yep.
process going on.
It's a
You've
continuous
got
process.
packing going on for the next STS flight, and
We
probably
had
a
repair
couple ahead.
operations happening,
Yeah.
and we had the defoul operations happening.
Okay, that's fascinating. What a picture! Did you take some of these pictures, or?
I took some of these pictures, but most of these that I printed, I was able to pull them off of some of the numerous NASA websites,
Okay, looks
NASA
great.
archives, and so forth.
I'm sure many of you are seeing some of these pictures for the first time from our guest Ty Bowen, parachute expert, taking us through the whole process here.
So, not the best picture in the world, but this was a really foggy morning. This is looking down the defoul deck, big long concrete area with the roof over it, and this is a main parachute that's all stretched out.
Tangled,
Yep.
way well tangled.
It's well tangled. You can see the floor's wet. We keep the whole thing wet. So I was hoping this picture would be a little better clarity, just to try to show how long this defoul deck was and how long of a mess these things were that we had to straighten out. So in this photo, this
Linguini.
is, yep.
A linguini machine.
So, yeah, I'm actually here taking some notes on some damage we found on a suspension line.
Okay.
So at this point, we've already got the canopy hanging on the hooks. The canopy is on the far side of the picture. We're looking at the skirt. We're looking at the bottom of the parachute where all the suspension lines come out. So these are all the suspension lines, all the spaghetti hanging out here. And we would go through, get all these pulled out, and we would drape them all neatly on the hooks, and then be able to roll the whole thing into the washer. So this is a
that.
photo. This would help you see, the ribbon construction of the canopy. This is the main parachute, and it lets you see the overhead monorail system and how they would hang them up on the hooks to get them ready to go in for the washing. There's one getting ready to go into the washing. You can see all the suspension lines are hanging here, and then you get to the skirt of the canopy, and then the canopy is suspended all the way up to the top.
You got to clean it before you repair it.
Yep. And we have to rinse all the salt water out of it. We would put it in the washer and keep rinsing it until the salinity got below the threshold that we knew we could roll it out of the washer and then dry it.
It's a lot of water. Did you have your own dedicated water tower for
Yeah,
this
we did.
system there?
We had a very large water tower. I can't remember how many gallons total the tank was, but if I remember correctly, the washing machine system was about a 30,000 gallon tank.
Wow.
30,000 gallon wash container.
Uh-huh.
And I never witnessed it, but I heard rumors back in the day when they had 2 or 3 working shifts, when they had a lot more flight activity. On break time, supposedly people would go swimming in it.
Okay. Why not?
Yep. I never witnessed it, but I wouldn't be surprised. That's just the door to the washing room. So it's kind of like a giant submarine hatch.
Yeah.
And it had these large levers here, 6 levers on the sides and 3 across the bottom, because the water level would be up about 3-4 feet, and then it had the overhead sprayers that were constantly spraying and cycling the water through.
On gentle cycle, because
On
you
gentle
don't
cycle.
want to do the fabrics, right?
Yeah.
Rubbing together.
Okay, so that's the extent of the SRB photo stuff that I've got.
Okay. Great. Fascinating. Really. I've never even been inclined to look up photos like that. So, Ty, thanks for sharing that. Quite an operation.
Oh, you're welcome.
What are we looking at here now?
So what we're looking at here, we call this the small lawn dart.
Okay.
This was a drop test vehicle that we used for testing the pilot parachute for the Aries program.
Okay.
When ATK was nominated the prime contractor for the Aries first stage and the recovery system, they subcontracted USA to design the recovery system, because we'd been managing all of the shuttle recovery system for the shuttle boosters. So this was a really fun project. We got to take what we knew from SRB and apply some new technology and come up with a bigger, better recovery system. But we did have some rough lessons along the way. And I wanted to point this one out in particular. We had an earlier version of this drop test vehicle that we did the first pilot drop tests with, tests number 1 and number 2. Mm-hmm. And this was the pilot parachute, which is similar to what you saw in the green pack over there. Okay. It's about a 10-foot diameter parachute. It's the first one that gets deployed from under the nose cone to recover. So it's a new design. We have to drop test it. This vehicle weighed about 1,500 pounds. And when we went out to do our third drop test, we were going heavier and faster. And unfortunately, the design team had made a minor miscalculation, and the webbing that we had connecting the parachute to the back of this vehicle wasn't strong enough. The shock load was a little bit higher than we anticipated. And what ended up happening is this vehicle went into the desert floor at about 500 miles an hour.
Oh.
And this was out at Yuma, Arizona, Yuma Proving Grounds. We call it YPG for short.
Uh-huh.
And you can look on the NASA archives and so forth. You can find some photos of all the different Aries testing that we've done. And unfortunately, we had an accident investigation and everything else with what happened with this parachute incident. But this was kind of a blessing in disguise, because we learned some valuable lessons on the small parachutes before we got to doing the big parachutes. The Aries drogue was 68 feet in diameter, where the SRB drogue was 54 feet. And then, as I mentioned earlier, the parachutes, instead of 136 feet, they were 150 feet in diameter for the mains. And those drop tests got very heavy. So a lot of the lessons we learned here with the little one really saved us some learning curve when we got to the big ones.
Now, is this transferred to the Space Launch System and the solid rockets on the SLS?
The solids on the SLS at this time are baselined not to be recovered.
Oh, okay.
So
okay.
unfortunately,
Didn't
all
know
of the
that.
parachute work that we did for Aries, that design package is sitting on the shelf. It's a shame. I'd love to see
Yeah,
it
really.
be
I
operational.
didn't think those were not going to be recovered, but okay.
Yep.
That's
So, I mean, the photo's a little bit dark, but the parachutes were in the back section here, and this front section was a big section of billet steel with some large weight discs behind it, and then it transitioned into a metal tube, and our parachutes are packed in the back. This was pulled out of a C-130, and then it slid off the cradle and became a lawn dart.
A big lawn dart.
It was a big lawn
500
dart.
miles an hour. Oh, there's the crater, huh?
Well, this was actually digging it out.
Oh, okay. Whoa, jeez.
Yep.
It really buried itself.
Yeah. I couldn't find my photo of the crater. We were maybe a half mile away from the impact site when we were testing this. We saw it come out, and we saw the pilot parachute deploy, and it instantly disconnected. Well, we had a system on there that when the 10-foot test parachute would disconnect, it was supposed to pull out, I think it was about a 50-foot recovery parachute. And that was done by, we called it a lazy leg. It was a webbing connection from the parachute down to the next deployment bag. Well, when that 10-foot parachute deployed, it immediately broke the webbing connecting it to the vehicle, but it separated with such a high load and so fast that it actually failed the webbing that went to the recovery parachute as well. So the recovery parachute never deployed. It stayed inside the vehicle. The vehicle accelerated to about 500 mile an hour and hit the desert floor, and it went about 40 feet deep.
My.
And the ground out there is rock hard.
Yeah.
And before it hit, you could hear it whistling like a World War II bomb coming in. And we could feel the ground tremble a little bit when this thing hit. When we got to the impact site, it looked like a small funnel in the sand that was only about 5 feet across and maybe 2 feet deep.
Man, just
It
right
just
in.
just swallowed right in.
Huh.
You know, so they got the track hoe out there and they dug as deep as they could with the track hoe. They had an experienced gentleman there that was used to recovering unexploded ordnance, because at YPG they do a lot of artillery testing. So he was used to actually looking at the ground and seeing where it was disturbed and able to track where these things went down through the ground. You know, interesting skill that took
Yeah.
me years to develop.
In Yuma, Arizona.
But these guys are actually standing where they had to bulldoze down, dig a trench down deeper so that they could back up the track hoe and dig even deeper to get to our test vehicle, because it had, we called them a data brick. It had all of our data acquisition
Like a
system.
black box
Like a
and
black box.
everything.
It was still on the vehicle, and we needed to get as much data off of it as
Sure.
we could. And they didn't want us leaving this out in the desert either. So it took them about a week to dig this thing out. And that's what it looked like afterwards.
Kind of intact, more than you think, huh?
Well, the front part, was solid steel, so it survived, but of course all the paint got scraped right off of it. Once it got to the tubular section of the vehicle, you can see the pressure just really squished it in. The recovery parachute was still inside here, and these are the Kevlar legs that broke that were connected to the test parachute.
Very interesting.
So once we were able to get these main bolts off and get the tubular section off of the weighted front end, that's what the recovery parachute pack looked like.
Man.
That used to be white spectral webbing, or white spectra cloth with Kevlar webbing, deployment bag construction. So that used to be as nice and clean as that.
Wow.
It got a little bit melted, it got covered with desert dirt, the parachute was melted and damaged inside. It was a mess.
Incredible.
But, as embarrassing and frustrating as this incident was, it really opened our eyes to paying a lot more attention to some of the stuff we were doing, and it paid itself going forward with a lot of the real big parachute testing that we did. So it's good to learn those lessons early in any kind of a program.
Exactly. Without people on board and no loss
Yep.
of scientific instruments and stuff.
So when we went to design the drogue parachutes and the main parachutes for Aries, we needed a bigger vehicle. And that is when we had that built.
Whoa.
That was our jumbo lawn dart.
Yes, okay.
And we tested this vehicle, I believe, about 5 times, 5 or 6 drops on this vehicle. And on the back
So
of the
it
vehicle,
survived, obviously.
Yes, this one survived numerous drops. So we had our pilot parachute pack here. We had the Aries drogue pack here. And then inside the white canister section here at the end was where the main parachute pack was. And we set numerous world records with this for the heaviest single loads extracted out of a military C-17 aircraft.
To land safely.
It was to do a single load extraction.
Gotcha. Okay.
Yeah, because they deploy tanks and trucks
Right.
and all sorts of stuff out of the back of these military aircraft, but it's usually numerous items that go out under separate parachutes.
Gotcha.
This drop test vehicle, this lawn dart, is mounted on a cradle, and the cradle and the vehicle would all get pulled out as one unit at one time with the extraction chutes. So since it came out as just one giant mass, they hadn't dropped any single mass that large before. So we set the record when we extracted 77,000 pounds, and then we went back and broke our own record and we extracted an 85,000 pound load.
Over 40 tons. Wow.
Yep. And our very last drop test that we would have done would have been the structural overload test, and that one ended up getting canceled because they had canceled the Aries program at that time. So we never got to do our structural overload test, and that would have set the record again at 90,000 pounds extraction load. And you can go on the websites and NASA archives and stuff, and even on YouTube, and you can Google NASA Aries drop tests, and you can see a lot of the Aries tests that we did here with this vehicle, and you can pull up a lot of the Orion test drops as well.
We'll do that to stay curious even further. Yes.
Yep.
I'd love to look at some.
Yeah, there's some really neat videos out there using this
Okay.
vehicle. So this is looking up into the bottom of Aries 1X. So these are the three main parachute packs, and going into an isogrid structure, which is similar to looking up under the frustum for the solid rocket booster for SRB. And when they were figuring out how to do that, they actually printed this. This was done on a 3D printer.
Show that up
Yep.
there for Marty to.
This was done with the design team with a 3D printer. I believe they printed this over at the ARF. And I think they had something on here that they changed, so it wasn't the final version, so they were scrapping this. And instead of going in the trash can, I thought, hey, that'll look cool on the coffee table.
Yeah, okay. Conversation starter.
Yep, conversation starter. So what you're looking at here was modeled here. These three parachutes would fit into these three large bays
Okay.
right there. So
A scale model,
Yep,
obviously.
this is
we're
a scale
looking at,
model.
1/10 or something like that, it looks like.
I
probably.
believe it's about 1/10 because the diameter of the boosters was about 12 feet.
Okay. Good guess on my
Yep.
part.
So what's interesting about this grid structure is the panel that the parachute rests against stops higher. The isogrid that was on the SRBs, these grids all came down to the bottom here. So you can see on the inside edges there's more exposed deployment bag here.
Right.
And they did that for a reason. The way that the isogrid was on the solid rocket boosters, when the drogue was pulling the frustum away from the booster's falling away, the frustum is rocking back and forth sometimes. When the frustum would rock over and the mains are deploying, the mains could be dragging past the metal structure of the isogrid on the SRB system. And that would sometimes lead to deployment bag damage, and it could
Tear,
also put a little bit
or
of
like the
damage.
friction from heat, you
Yep.
said.
It could
Wow.
damage the canopies, and it would damage the bags, and we would have some repair work we had to do. So they kept that in mind when they designed the Aries grid structure, and they shortened these instead of extending to the bottom of the main packs. They held them up a little bit. Little did we know that was actually going to hurt us a little bit. So when you solve one problem, sometimes you create another. So here this is an Aries drogue getting packed. It's conical shaped to go into we reused the frustum from SRB for the 1X test flight. But because of the pack density of this drogue, we had to go to a larger spider press. So this was a much larger,
Gotcha.
stronger
That's
press,
your
put a lot
spider
more
press,
pressure on it. to get him packed.
So again, this is to bring back the first stage of the proposed Aries rocket,
Yes.
right?
Yep. This
That
is
got
being first
scrapped,
stage.
and you can see the amount of energy, brains, and thought put into this program that never matured.
Yep. We got it pretty mature, then
But
it got
not-
canceled.
Yeah.
Yep. So here we have the Aries 1X launch. And
Trying
instead
to
of,
think, 2014, 2013.
I think it was 2011 or 2010.
Yeah, it's been a while. And,
Yep,
and
it was a
they-
while. And I know on the SRBs, they called it the forward skirt extension and then the frustum. For this one, I believe, for Aries 1X, I think they called it the interstage
Okay,
system.
that'd be up in here.
Yeah, it's going to be right about here because the second stage, it actually flared out. And the top stage, the top dummy second stage, was actually a larger diameter than the first stage on the bottom. So above this section, it actually flared out.
Gotcha. Okay.
So when the second stage separated from the top of this first stage, the drogue parachute actually sat inside this ring. It sat right here.
Oh, okay.
So it had the pilot parachute pack on top, then it had the drogue pack, and the drogue was connected to the fittings around this ring. So when the ordnance ring here at the bottom would fire, so you've got 5 motor segments that are below this section. That's the 5 segment boosters below this. The drogue is connected here, the drogue is inflated up here. This ordnance ring would fire, the drogue would keep decelerating this, and the 5 segment booster would fall away from underneath here. And as it fell away, it would pull out these 3 main packs.
Uh-huh.
So it's very similar to how the frustum behaved on the SRB.
Right.
Only it was cylindrical instead of frustum shaped. And then the isogrid didn't come all the way down to the bottom of the pack. So unfortunately with Aries 1X, when the boosters hit the water, they were going much faster than we anticipated. And this is an underwater photo. There's a diver there. And this photo is available online. Hard to tell here in this photo, but the side of the booster has a large dent right here.
You can see that, yes.
Yeah, the booster hit much faster than we wanted, and it actually buckled this motor segment. And I haven't measured them myself, but I heard that the steel used on these motor segments is about 1 inch thick.
Wow, some impact.
So it took quite a load to buckle that motor casing. And when you look at the videos for 1X, you may remember there was a parachute anomaly that happened.
Okay.
What occurred is one of the main parachutes, when it was deployed, it went straight to the second stage inflation diameter. It bypassed the first stage, which is the smallest size, and it went to the next size of inflation. We control the loads that the parachute sees by controlling the inflation diameter with reefing lines. A reefing line is kind of like, just picture like a shoestring that runs all the way around the bottom of the parachute and it draws it in.
Okay.
And we would use a reefing line cutter, which is a timed pyrotechnic device that gets activated when the parachute deploys. That reefing line holds the parachute at a diameter that it won't overpressurize and dynamically overload and have a structural failure. So once the load dissipates, those reefing line cutters fire on their timed sequence. It cuts that reefing line, which then lets the parachute inflate to the next size. And then the second stage cutters would fire, and then it would go to its full open diameter. If the parachute goes too large on initial deployment, it structurally overloads, and then it fails. So what happened with Aries 1X is, and this is what the accident investigation has concluded, is one of the reefing line cutters was accidentally activated inside the pack job. And the way that we figured that happened was the pack density for the Aries 1X main pack wasn't as tight as our test packs were for all of our drop testing, and it wasn't as tight as what the SRB packs were. So during the tumbling on re-entry of the first stage, these parachute packs were slopping around inside here. They were banging around.
I gotcha. They didn't have the extra.
So the grid didn't
grid.
come all the way to the bottom, so that didn't help stabilize it. But then the pack also wasn't as dense, so it had more freedom of motion. And they've got video looking up at the bottom of the Aries packs on the test flight, and you can see these packs are moving around quite a bit.
Wow. What
So-
an interesting conclusion.
So that motion inside the pack snagged the activation line that went to the reefing line cutter. The cutter fired inside the pack job before the parachute ever deployed. So the one parachute deployed immediately to second stage, which aerodynamically overloaded it, too much ingestion of air, too much pressure, structural failure. And then when that parachute was flailing around, part of that parachute then damaged its neighboring parachute because it was a cluster of 3. And we landed under a little bit less than 2 inflated parachutes. That's why the landing velocity was higher, the impact was heavier, and we ended up buckling the motor segment.
Okay. Very interesting.
That is a reefing line cutter. The size of this is, it's about like 2 decks of cards or 2 packs of cigarettes in
Gotcha.
size. This is the sear pin. This pin, they just tied it here so they wouldn't lose it. But this sear pin is normally located right here. And this lanyard is connected to this end of that sear pin. And on deployment, when the parachute stretches out, this pin would get pulled, and then that starts a fuse train that's on the inside here. It's a black powder fuse train. They build very precise fuse trains down to like 1/10 of a second.
My.
So they would have a predetermined burn duration, and we would have them built to that burn duration. And when that fuse train would burn for, say, approximately 8 seconds, then it would fire the main charge, which then propels a blade into this aperture area, this opening here. The reefing line is passed through this aperture. Well, when that blade severs that line, now the parachute is free to inflate to the next size. So what happened on Aries 1X, we believe this sear pin, the fabric from the motion inside the pack actually pulled this pin out.
Gotcha.
The fuse train burned, it fired the blade, it cut the reefing line before the parachute was ever out of the bag.
A fuse train is all I can think about is a western, and they're lighting the fuse to bomb to blow open the mine opening in there. But that's what's going on here. Is the same kind
that's
of
what's going
fuse
on.
going in there? That's
Yep.
and that's about 8 inches. You say something
Yeah, it's
like
about
that,
8 inches long. They're about 1 inch thick.
Yeah.
These are
That's cool.
These are the
That's-
cutters that were used on the SRB mains and the SRB drogues.
And this is technology still used, do you think, in
Yes. Yep.
Starliner landing on? I mean, how can they get around this?
They're using some smaller cutters than what these were.
Right.
These were some of the biggest cutters
Yeah,
that we've
but-
used.
but
Military
still,
uses
the
these
same
this big.
concept. No matter
Yep,
what
same
size.
concept.
Interesting.
Actually, this is a reefing line cutter,
Is that right?
and that one is live ordnance. We actually
Okay.
use this one in sport and military skydiving for some small applications that we do. So it
Marty
still
can
has.
show that there.
Yep. We still have the safety pin in it, but this would be the sear pin. This is where you'd connect the lanyard. And when you'd pull that lanyard, the small fuse train would burn inside, and then it would fire the projectile to the aperture, and whatever was placed through this little aperture gets cut.
I'm
So-
fascinated by the pyrotechnics here. I knew there was a lot going on with the parachutes, but
Yep.
this is
So
way
this
more
one
than I ever
is-
considered.
Yeah, this is a 1.5 second timer.
Interesting.
So if I pulled this little pin in 1.5 seconds, the fuse train is burnt, it fires the main charge, and it would drive a blade through this opening, and whatever cord was put through there would get cut.
Marty, was any of that technology part of the lunar module and the guillotine? Is that a completely different type of pyrotechnics, huh? You didn't have any fuse trains on the moon.
Never heard of it.
Never heard of it. Okay. Well, we haven't heard of a lot of this stuff. We're here with Ty Bowen, and I know we've gone kind of long, but that's all right because we're learning things that you never even thought about before. You got a question there?
Just for Bruce.
Oh, okay. Oh yeah, Bruce, well, you're your former skydiver. Wanted to ask you about being
Okay.
a skydiver.
About
in
being a
there.
skydiver?
Yeah. Well, what else you've got to show there? Let's show the rest
Okay.
of your pictures.
Well,
whenever.
that was the large cutter. And this one is labeled number 120, so I would say that one came off of a SRB main parachute.
Okay.
That was located at Gore number 120.
All right.
This is a picture of a reefing line cutter that would come out of an orbiter drag chute. So these were smaller.
Okay. The drag chute that we showed you on the back come out of the rudder of the
Yep.
shuttle to
So
slow it down on
there's a
landing.
reefing line that was on that parachute system as well. And it's a little bit larger diameter than this one. And these were made out of stainless steel, where this one that I brought in is aluminum. And the reason they reefed the parachute on the orbiter drag chute is it's mounted up pretty high on the vehicle. And they would usually deploy that right as the main landing gear would hit. If it went to full inflation, it would actually hold the nose of the shuttle up longer, and it might even actually try to make the nose climb.
Gotcha.
They're wanting to make the nose go down for the landing.
Uh-huh.
So they had to lower the drag force when it would initially inflate, and then after a certain time period that these cutters would fire and the reefing line would get severed, and it would allow the orbiter drag chute to go to full inflation. So they would hold it at the first stage, let the orbiter decelerate, get the nose gear down, then it would go to a full inflation.
Some amazing physics going on here.
So because of the Aries problem, the Aries 1X problem with the reefing line cutter that misfired, we had to redesign the cutter pocket to protect that lanyard from getting snagged.
Gotcha.
The SRB parachutes for shuttle flew 135 flights, and that would be 6 main parachutes plus 2 drogue parachutes per flight. So we went through hundreds of cutters.
8 times 135 is over 1,000.
Yeah.
1,020
And
something.
to the best of my knowledge, we never had an accidental cutter firing.
Oh, wow.
Of the 270 solid rocket boosters that flew, we only lost 4 of them.
Okay. Early in the program, too, I
Yeah.
think, right?
I believe it was on
STS-2?
STS number 4,
Yeah.
and I believe it was attributed to a lightning strike. And the lightning strike did something to, I believe it was the deck fittings that were originally on the drogue. They went to, they didn't, I believe I'm remembering this correctly, they went to a different connection method, but they believe the lightning strike accidentally activated those, and then when they went to deploy the mains, the drogue was already separated, so the whole booster splashed down.
Uh-huh.
And then of course we lost the 2 boosters that were on Challenger.
Correct, yeah.
So we had to come up
So
with...
technically only 2 boosters through the whole
Yep.
parachute system in there.
But the SRB cutter pocket, so here's the bottom of the parachute. This is an Aries parachute. And then this is the parachute canopy section here, and the suspension line's coming down here. This is a big felt pocket that has that large 8-inch cutter inside it. And this is the activation lanyard. And you can see it's exposed right here. And this is very similar to how all of the SRB cutter pockets were done. And it never had a problem.
Okay.
But the pack density and the ability for the parachute packs to move around inside the 1X configuration got that to snag on the inside. So I was actually part of the design team for this, and I came up with a design for the pocket that completely covers the lanyard.
Okay.
I
we see
extended
that. Yeah.
the felt fabric all the way up to completely cover that. So basically, a few dollars worth of felt fabric by extending this cutter pocket would have saved the day for Aries 1X.
Wow. And you engineered that. That's cool.
Yeah, I did that one.
All right. Huh.
So that was one of those expensive lessons learned.
Exactly.
And this is the jumbo drop test vehicle. This is getting ready to land out at YPG, Yuma Proving Grounds. This is under the 150
Yuma,
foot.
Arizona.
Aries
we saw
main.
that earlier. That set the record for the most dropped out of a
Yep.
sea.
Heaviest single extraction. And then we did one cluster test, and this was with a weight tub, and we had about 42,000 pounds in here. So this was a cluster of 3,
Uh-huh.
and we were getting drag information on this, because when you have a cluster of parachutes, they don't just add the drag area times 3. You have a cluster degradation factor because you can see these canopies aren't straight, they're tilted out.
Yes, okay.
So the drag area is less because it
Uh-huh.
isn't directly over the load. So you have to figure out what that drag area is going to be. Plus, when the parachutes are flying next to each other, it's pretty hard to determine from the spillage coming out how far apart they're going to go. Guys that are pretty good at calculating that can get it close. I've not been able to figure that stuff out myself. It's pretty technical, but we had to go do this cluster test so that we could see what the degradation factor was in this configuration, and then we would have a better idea of what the splashdown velocity was going to be for Aries 1X.
And that worked well.
Yeah, this worked well. This was again out at Yuma Proving Grounds in Arizona.
Cool looking parachutes too.
Yeah, they were pretty.
What a lesson here on parachutes, huh, Marty Winkle? I've never imagined some of these things going on and all that's involved in it and the technology. Ty Bowen, you're really giving us a great lesson here all the way around. Tell us a little bit about your personal jumping out of perfectly good airplanes with parachutes. You're still doing it, I imagine.
Still doing it, not as much as I used to. I used to go about 150, 200 jumps a year, and that's low numbers compared to some of my friends, some of the professional competitors and people that work in the industry, instructors, jump masters, video guys. There's guys out there who do over 1,000 jumps a year.
That's like 3 or 4 a day.
Yep.
Yeah.
So they're doing it full time. I've been jumping since 1990, and I've got a little over 2,000 skydives.
Awesome.
So I really haven't been jumping a whole lot the last decade. I might do maybe 5, 10 jumps a year at the most.
What's one of the more memorable ones? I'll ask you, did you jump during the Great American Eclipse? I know
I
some
didn't.
jumpers did that during
No.
the eclipse we had 3 years ago.
I didn't get a chance to do that.
And,
Unfortunately, I never got to do a jump during a shuttle launch. I was here in Florida, but I had a lot of friends that would come to the Titusville drop zone here right up the street.
Right, yes.
And they would actually do shuttle loads. They would try to time it and be in free fall when the shuttle was launching. I wish I would have done that. You know, in hindsight, I missed a good opportunity.
To see the
there.
shuttle from your
free
canopy
fall.
or your free fall. Wow, that-
Yeah.
Yes, we are just within a few miles of a jump situation
Yep.
at the small
Yeah,
Titusville
drop
Airport
zone's
here.
right up the street at
Yeah,
Dunn Field.
I love seeing them on Saturday. You'll see 5 or 6 of them. Look up and just see them all coming down over the
Yeah.
city and landing over there.
Yep.
And
Most of my jumps now, I'm doing test jumps or I'm chasing out some unmanned project that we're working on that's being
Okay.
tested. So.
well, I have really enjoyed this, Ty. Is there something we asked you that you wanted to share about your career? We appreciate you bringing all the
Well,
things.
I did mention something interesting about that webbing I was going to show
Yeah,
you.
bring that over here.
When
Show-
I believe it,
bring
I
that-
believe it was this vehicle. This was when we did drop test number 3 on the Drogue.
What was that piece
That's
of
a
metal?
piece of metal.
Oh, okay.
That was from when the small lawn dart went into the desert.
Oh my God! You got a little souvenir of
so
that.
that's some S-
40 feet into the.
Yeah, that's some S-folded metal that used to be an iron channel that was welded on the vehicle.
Oh man! Wow.
It's a little bit different shape now.
Yeah. It's like a meteorite.
On Drogue drop test number 3, yep, this vehicle actually ended up sticking in the ground like a dart.
Okay.
On all the other drops of this vehicle, it would hit and then it would fall over. So now we had, I believe that was about 77,000 pounds, was just stuck in the ground waiting to fall over. So it was very dangerous for us to get to it, and
Yeah.
we're trying to figure out
30 tons. Yeah.
how are we going to gently lower this thing down without endangering people or equipment. Well, we had all these main parachute risers were hanging off of it. They were hanging off the back end of the vehicle. So we brought a large mobile crane out to the drop zone and took one of the main parachute risers, and we tied a giant knot into it and made this loop, and we put this loop on the crane hook, and we used the crane to start to pick the vehicle up to where it was stood it upright, and then the crane operator took it sideways and was able to gently lay it down. So this overhand knot that was done about 10 years ago It's hard as a rock.
Wow, the tension that pulled that together.
Yep.
My gosh, that
So
is amazing.
That lifted the
So
vehicle and
that's
laid
off
it
of this
over.
picture right there. That's
Yeah,
cool.
this is one of the main rises.
That's cool, Ty. Yeah, that's like, I mean, it's like molded there.
Yeah.
Wow,
Yeah,
you
it's-
could never, all of you that like to untie things, you know,
You won't
never
get this one
you'll never
untied.
get that knot untied.
Yep.
Well, that's a
It
good
is
way
very tight.
to end your little program here. You know, we bring you things on Stay Curious that you'll never see again, and this is an awesome program that we will put on our YouTube channel. Is everything you want to know about parachutes. Ty, before we let you go here, we want to thank you very much for spending your time putting together this little program for us.
Oh, you're quite welcome.
We're going to end our program with something that we always like to do, is a little space news, and we've got an astronaut birthday, Julie Payette,
Yep,
the
I
second
remember Julie.
Canadian astronaut to go to space. She was on STS. It's her birthday today. Happy birthday, Julie Payette. She's 57 years old. She was born in Montreal, Quebec, Canada. The second Canadian female astronaut, spent 25 days in space on STS-96 in 1999 and 127 in 2009. So those SRBs that took her the first 20 miles up, you helped land them, Ty.
Yep.
This is an amazing woman. She is currently the Governor General of Canada for the last 3 years. What's the Governor General of Canada, you say, Mark? It is she basically carries out the Canadian monarchy constitutional and ceremonial duties of Queen Elizabeth II. So she's an extension of the Queen in Canada, and you refer to Julie Payette as Her Excellency or the Right Honorable Julie Payette. And she speaks 6 languages,
Wow.
plays the piano, and has sung with the Montreal Symphony Orchestra, a vocal group in Brazil, and she's played piano with the Tafel Music Baroque Orchestra in Toronto. So what an amazing lady, 57 years old today, Julie Payette. And she is, like I said, the Governor General of Canada, Ty. And so I just had to look up, how much does the Governor General of Canada make representing Queen Elizabeth II? 200 grand a year. A little more than what astronauts
yeah,
made,
that's a little
don't
more.
you think? So,
Yep.
so happy birthday to Julie Payette there.
Yep,
And
happy birthday.
to her. So we've had as our guest Ty Bowen, and we have certainly enjoyed you spending your time with us. Marty Winkle, my co-producer, is bringing you some of these wonderful space workers that we've just got a chain link going of bringing you new quality people every week. 2 people a week now we're bringing you as speakers. Thursday, you're not going to want to miss Gary Harris, who not only knows about everything about spacesuits, but he actually builds spacesuits. And he's going to be in front of the one that he loaned us, the Artemis spacesuit, Thursday, and tell you about that. And it'll be as much information as Ty Bowen has graciously given us today. I learned so much, Ty. Can't thank you enough for being here. Don't be a stranger of the museum. By the way, what do you think of our humble little space museum?
I think it's a great museum. I've wanted to visit it. Now that I've seen parts of it here, just coming here to do this interview, you have a lot of stuff here.
Yes, thank you for authenticating some of the parachute things we
you're
have
welcome.
here.
I definitely want to come down. I want to take a real long time to go through, see everything you've got here. It's very impressive. I like this.
Good. Well, we celebrate the birth of the American space age and inspire the next generation of space workers just like you, Ty. So Marty and I will be with you tomorrow. We're going to do a special show. We're going to try to bring you the 1238 launch from our little balcony spot over the river, and then come back at 4 o'clock from the same spot and show you the construction that's going on at Spaceview Park as they finally, 3 years after Hurricane Irma, are cleaning up the boardwalk that so many thousands of you watch shuttle launches from. So
Yep. It's a good vantage point.
Yep. And they're finally fixing it up, and you'll see for yourself on Stay Curious tomorrow. So I'm Mark Marquette, and we're glad that you've been with us with Ty Bowen to bridge the space between us. We'll see you tomorrow.